Welcome back to the channel, guys, with me, Ibra. I really appreciate you guys tuning in because I'm quite excited to finally share details of the first home lab project that I've been wanting to do for quite a long time. And in my opinion, I'm going to produce another follow-up video why it's going to be one of the top 3 reasons for the first 3 projects that you should set up on your home lab straight away. And that is network attached storage, also known as NAS servers or NAS drives. In this instance, we are using Raspberry Pi, and we're using the Raspberry Pi in a multidisciplinary kind of way where the Raspberry Pi will do multiple things and a NAS drive will be one of those things. And that's kind of where you get more value for money, more bang for your buck, because there are big players that operate in the NAS server market, especially for home users, and the prices do tend to stack up and climb quickly. And you don't get the hard drives that come with them, and you can spend an astonishing amount of money where they start offering you some serious compute, which should make you question why not just build a proper miniature home server with an Intel or an AMD chip in there? Because these guys are offering you 8 gig of RAM, they're offering you quick NAS server side storage with SSDs, and then kind of long term storage with hard drives. And it can get quite complicated, and it comes down to what kind of problem are you trying to solve and how much money are you willing to solve it. And my hope is I can appeal to you by telling you, look, you don't have to spend a lot of money because Raspberry Pi can offer you a very comprehensive range of compute options to meet your needs. 16 gig is the latest, a more expensive variant. When I built mine, I went for the 8 gig variant. And to be honest with you, that's kind of what's running now in the background, albeit it's not doing very much because this is the first project that I wanted to set up on there. A NAS server doesn't actually take up a lot of compute. It will end up stressing your network connection as you start to stream files through it, put videos on there and things like that. Once again, I kick the ball into your court. What kind of problem are you trying to solve? I want to try and keep things cheap. I don't want to spend £500-600 creating a NAS server. There are new players entering the market, but Synology are the big players in this market. And when they offer you serious compute like this, so where is it gone? What they're also trying to tell you is that you can run your home containers on there. Docker software can run on there. You can run Plex server and all these other things, Pi-hole on there too. And I personally think, why not just use proper dedicated hardware? A NAS server isn't really designed to solve that problem. Its main problem is to actually give you storage space on your network. And more importantly, the memory and the CPU they'll give you will always be inferior. So always bear these things in mind. The prices stack up very quickly because you've got to buy the hard drive separately, which once again, you've got to buy NAS compatible drives. Seagate Ironwolf is the one that comes to mind straight away. And you can actually buy a very cheap Raspberry Pi server, set it up, watching my videos as you've probably seen so far. Thank you for tuning in so far if you have. And then you could just give it the dedicated job of just being your NAS server. And you could probably spend maybe 60 quid getting the cables, getting the network cable, getting the power cable. So bear that in mind that it's not just £48. You've got to buy the cable, maybe put the operating system on. I would always recommend, at the bare minimum, always use an NVMe drive for maximum space and speed and efficiency, because this honestly is not great. It will do the job. Once again, it depends on what problem you're solving and how much money you're willing to spend on that problem. But for me, I will be sticking with Raspberry Pi. So let's kick things off. Now, if you've been paying attention to my videos in the series so far, the last video that I kicked off on the channel, which was 3 ways to connect. So if I go to my YouTube channel, you'll see a new video has recently been uploaded. So let us go here. And there is 3 ways to connect. Now we're going to make use of those 3 ways to connect to the channel straight away, because in the last video, I showed you how to connect via SSH, which I'll be doing in a minute. And the next thing is I showed you how to connect via remote desktop like this. So this allows me to get in. I made my login journey seamless. I've got my terminal session. One thing I did to try and make life easier for these videos is that I actually configured the terminal experience from here. So I actually set terminal font and a font size. Because honestly, you do have to start squinting a little bit because I am on a 4K screen. So the command and text do become quite small to read. So that's something I've learned from the last video. The next thing we're going to talk about is the behavior. What happens for you by default when you first plug in? Similar to Windows, Windows will automatically configure your drive, mount it, set it up, and then give you instant access to it. And Windows doesn't really bother you with permissions quite a lot. That's one thing I really like about Windows. It's give you that Apple feeling that Steve Jobs used to famously talk about, which is the user has to start managing their operating system and their environment. They stop becoming a user, they become a janitor. That's kind of what I like about Windows. Windows doesn't really bog you down with these things. But when you mount your Raspberry Pi external hard drive, I picked the Samsung T9. There'll be a short for that coming up real soon. It does some really cool automatic things for you straight away. It will auto mount the drive for you. It'll pop up, it'll give you this little drive symbol with the eject symbol, which means you can eject it and safely remove it. What that will do is it will auto mount the drive for you under your media folder, and then it'll pick the user that kicked off the mounting process. Now, when you plug in for the first time, it should pop up under your primary Raspberry Pi user, and then in there, only your primary user will be able to get into it, and that creates an access problem, and that's one of the reasons why we need to get rid of it and remount the drive, and that will be coming up in the second part of the video. But just to highlight this issue, right? If I was to, in using my desktop user, this is the one I set up for convenience and access. I can CD into the media folder like this, and then I pick my Raspberry Pi user RDP, and then if I go into the mountain location, so the name T9 is defaulted. You could probably change that as well. I can list its contents fairly easily. If I wanted to use my other user, she's actually got a lot more permissions, which is why it was really useful having SSH access for both of you this way. So if I now SSH in using my primary Pi user, now that I'm in, if I actually tried accessing the same location, so let's try and get into here, we're going to get an error message. And this, for me, is another reason why we should get rid of this auto amount and redo it manually. So C drive, change directory into media, and then we're going to pick RDP like this, and then we're going to pick T9. It doesn't even auto complete, which would give you the first clue. And it doesn't let you list the content of your mounted location, which is conveniently under the Raspberry Pi desktop user. So that creates problems for us. So I'll create some notes. So Raspberry Pi auto mounts the external drive for you. The owner assigned to the mount is the primary user. The operating system will auto assign the default location. You will get a nice drive-like icon. This kind of creates the next question is, well, what's wrong, right? Why can't I just get on with it and start using it? This typically assigned to your primary user, and that's actually not your remote desktop user. And you really want convenient and easy access. You want to be able to just quickly go in, drop files in, view what the files in there, copy them, whatever you need to, any kind of editing you want to do. And you just can't do it because the ownership is assigned to your primary Raspberry Pi user and not your convenience user, which is the RDP one. So you want to try and remove the mount, unmount it, and then remount it with more open permissions. This means that when you remote desktop into the server, you won't be able to access the mount. You can get access to the mount via your SSH using the Raspberry Pi user, which we just saw, but it's now blocked. And in most cases, you need to remount the drive. So this means that we need to unmount the default media auto mount. Then we need to remount it with open permissions, like I just said. Remount as the media type location to get the nice icon. Hopefully, that we'll be doing that next. Try writing a test file, which we will do, and ensure the media mount is also auto-mounted on reboot. So we'll be checking the ls bulk command, and then we'll be checking the contents of the fs tab file. Now in the next part of this video, we're going to connect to the Raspberry Pi server and remove the auto mount. Now I use a utility called PowerToys, and that's got this really powerful feature called PowerToys Run, and I use this pretty much ubiquitously every day, everywhere, and this is pretty much how I like to navigate on Windows. And we're going to use it to connect to our Raspberry Pi server, which is pretty much running all the time. You've seen this XRDP login session window before. And now that we're in, I already have a terminal session window open. When you plug in your external drive, what should happen is that the Raspberry Pi operating system should automatically recognize the drive, mount it onto the media location, give it a default name, and give it this nice, cool drive icon. So it gives you the impression that it's an external file system that you can use and connect with. This is the default experience. This is what should happen for you every time. And when you use things like ls bulk, you can see that it's automatically default mounted for you. It's got a unique UID to identify it, tells you the file system, and it also tells you the name of the drive that is unique that the operating system can use to go and find it. Now, we want to remove this auto mount. That's what we're going to do in this part of the video. And then we're going to remount it with a special folder permissions and using a special group that all of my users are going to be attached into. So that's going to be the next part. So let's kick that off next. So let's just go back into the Raspberry Pi server. And what we're going to do is we're going to try and finally remove this mount. And we've got a Gemini script, which I've been preparing for quite a while. And we're going to follow the script slowly, step by step. It should have everything we need in there. Before we do that, I've also prepared some removal, the unmount command. So we're going to lift this. Now, if you're lucky, you could just use sudo. I haven't bothered to set up sudo. I actually set up the root user instead. So that's how I dip into it. And then I can just unmount the drive like that. And then when I do lsblk, it should confirm that there's no longer a mount point for the T9 external hard drive. Now that is awesome. The next thing we're going to do is we want to check and see if there's still an entry in the fs tab like that. And you can see in the fs tab file, you can see that there is no longer an entry in there anymore. Now this is awesome. This means that we've removed everything that we need to remove, and now we can start re-adding the mount in with a new folder and give it special permissions, which is what we'll do next. Now let's move on to the next step, which is to start adding the packages that we need, following on from the Gemini script, which I prepared. So there are a couple of packages that we need to get this to work. So this is going to be apt-update. That did not work. Oh, it's actually separate. Do that. And then the next thing we need to do is not an easy way for me to copy. Put that into here so that we can copy it into the terminal. So this is one of the packages that we need. Make sure you have this installed in your machine. Makes it easier to manipulate file systems and groups. And once you have that, the next thing we need to do is get the external drives UID, which is what we saw earlier, this one, and copy that, put it into your clipboard, put it here. As you can see, I've already started building a command from when I had this working previously. So it should be the same. UID, that should not change. The next thing is we need to start identifying the users that we want to add to our group, which is going to make life easier from a permissions perspective. So if we type in the name of the users that we're interested in, that's one of them. You can see that groups, and the main one that we need is this one, global unique ID. And then if we do the same thing again and we type in the other convenience user we set up, that should have a slightly different user, and it's going to be 1000 and 1001. And those are the actual two you need. So if you look at the prepared command I've had from before, you can see that we're going to add it to another global unique object called 1002. So 1002 should be the group that we're going to add. As you can see here, it's nicely remembered and given us a clue as to what the output should look like. Now we're going to add the group that we need. So this is going to be a group. Let's go and lift this. So put that there. This is the group that we are going to add all our permissions to. It's going to manage things for us going forward, make our life a lot easier. That's created a group for us. You can see there, it gives us the global unique ID once again, 1002. So it should be nice and convenient going forward. The next thing we're going to do is we're going to add our users to the group. So put this back into here because you can't copy and paste directly. The terminal will not accept it. It's the only way. So that in that way, and then put this one as the remote desktop user. Now that our users have now been added, we've already got this, but for the sake of just being really pedantic, we can go ahead and confirm the unique ID 1002. So that should be in line with what I had previously built here. We're at the stage now where we need to actually start creating the directory we want to mount. So we're going to create a brand new mount directory. We're going to call it, we're going to put it under the main user anyway, because the main user is the user that needs to own everything in my view. So we're going to use the make directory command, and we're going to put a brand new mount location or mount folder called MNT under the main Raspberry Pi user. Put that in there. The next thing we're going to do is we're going to set the permissions up for the group on that folder. So grab that again. What this will do is this is now going to give us read and execute permissions, I believe, to the parent directory, which is going to contain the mount folder, which we just added. So this is the folder, that one. And then the parent directory, which is the main Raspberry Pi user, we're going to add our storage user groups into that folder. So then at least this will then share out all the permissions down to anything that lives underneath it. So put that in there. And then the next thing we want to do is this command gives members of the storage users group permission to pass through this directory to reach our mount point, which is exactly what we want, because this is also known as the ACL access control list. This is the issue that I ran into before, where I just could not, for the life of me, figure out how to get into the folder. It was just blocking me. So the next thing we're going to do is we're going to add an entry to the FS tab file. So I think it might be in the history. Should be etc FS tab. Now we're going to add our entry in here, and this should pretty much look just like this. I'm going to double check it just in case. So that's the UID we're trying to mount. That's the location we're trying to mount to. That's the file system we're trying to use. We should be global unique ID 2, because that's what I had before. And just to compare it, and we're going to add it in here. So now we're going to go back into the FS tab file and copy the command we're interested in. And we should be able to right click and paste the command we're in. And then we press Ctrl X to save and enter. If you go back into it again, it confirms the changes are actually still there, which is what we want. Now let's go back to Gemini to confirm the next bit. And now we need to actually mount the external location. So it's just mount-a, use systemctl daemon reload. Let's just do that anyway. I think we can solve this just by doing a simple reboot. Now we do ls bulk again. We should have that in our history. ls bulk. This confirms our location has mounted to our external drive has been mounted to a brand new place, that the location we selected, which is amazing. And the next thing we're going to do is we're going to verify that the permissions have changed. So we want the list command like that. So that looks pretty good. That's what we want to see. It confirms exactly what the Gemini is telling us. The next thing we need to do is we need to reboot the machine. Shouldn't actually take long, but then we'll pick up the video again from there. Now this is the final part of the video, which is to confirm that the permissions and that everything we've been following in our Gemini script has actually worked out. Now, we don't have to go into remote desktop again. We can actually verify everything just using terminal with separate SSH sessions. Now, I've gone ahead and connected to both on my Raspberry Pi. Main Pi user, the one with all the permissions that Raspberry Pi give you for free when you first set up the operating system using the imaging software. And then this is the convenience user we set up via the XRDP connect portion of the last video that we produced, which was 3 ways to connect. Now, I've colored the tabs, I've given them appropriate names. You can tell the context and the difference because we desperately need our remote desktop user to have the access and permissions it needs. Because as you would have heard earlier in the video, you just don't have any access because everything is locked to this user, your main Raspberry Pi user. So we've got two SSH sections open, and Gemini has gone ahead and given us a head start. So it's told us where we need to change directory into to verify that we can actually list out the contents of the directory. This is good. This proves that we've got permissions to list the contents or read the contents of the directory. The next thing we want to do is be able to verify that we can actually create temporary files in this directory. And then we want to be able to verify that we can actually edit and write to the directory. So if we do another list, you can see that it's actually wrote a brand new file. It's actually added a brand new empty file of 0 bytes to the directory. And that's exactly what we want to see. What we want to verify is that we can actually edit the contents of the file. So if I press, put some text in there like that, and then press escape and press quit, verify that the content have saved. I think it's right quit like that. And that verifies that what we asked for is actually there. Awesome. So if we do just quit like that, we can actually go back to our other user and we can cut out the contents. Now that verifies that our actual setup is all there. We can freely now do everything we need just using a terminal session and just using SSH. And then we can also connect into our Raspberry Pi virtual machine. Well, not virtual machine, but you can connect into the operating system like this one before. So now we've connected back to our Raspberry Pi, and we should be able to go straight back into the drive. You can jump straight into it, and you'll notice a familiar looking file. And this is the file we wrote to. And amazing. And the contents of exactly what we asked to be written. have been saved to the file. We can close this file now and we exit the operating system like this. Just kill the session like that, disconnect the session, go back into our terminal, and then we will cut out the content, and it verifies that actually the contents have indeed been updated and reflected instantly. Now this, guys, is the end of the first part of the simple NAS project video. The second part of the video is going to be setting up the Samba share that is going to be used to expose the newly configured mount that we've just made for the Samsung T9 drive. We're now going to expose it so that we can have access to it on Windows, and then we can actually start using it as a proper network mounted share. So thanks for tuning in. I really appreciate it. Thanks for sticking in with the video. After a while, there's quite a lot to it. The videos turned out to be a lot longer than I anticipated, but I appreciate it. Thank you for tuning in. So this is the final part of the simple NAS project video, and this is the exciting part of the video where we finally get to take advantage of all the config and setup work we've done with regards to removing the default mount, resetting it up again, reconfiguring the users, adding a new group, permissions, all that legwork that we've put in the first part of the video. We're finally going to take advantage of it by exposing the new network location that we've set up on the Raspberry Pi as something called a Samba share. Now, Samba shares is quite a rabbit hole, so I do recommend you consulting your favorite search engine and having a bit of a read of something called the SMB block, secure message block protocol. If you want to know more about it, server message block and Samba shares. Right. This is the technology that we'll be using to help us expose our network mount that we've just set up, our Raspberry Pi mount that we've set up in the first part of the video. Now, essentially, the ultimate goal of what we're trying to do is we're just trying to be able to set up a network location where we can access it at this present moment in time using the raw IP address, which we set up in previous videos, where I went through the trouble of helping you understand the benefits of coming up with memorable IP addresses using a memorable naming scheme. Ideally, we want to use something like a DNS name, which we will set up using a Raspberry Pi hole server, which comes with the DNS server. So we could use something like Raspberry Pi.local or RPI.local, which make it significantly easier to get into these places. But this is the ultimate goal. We want to be able to access it from Windows Explorer. You want to get into your default share location, which the Samba share, the configuration guide, which Gemini has set up for us. Gemini has been a massive help, and I cannot vouch for how easy these chatbots make navigating Linux when you're a complete novice like myself. And if you do want these setup guides, I'm happy to share these with you guys. So do please drop a comment if you want these raw guides that Gemini has produced for me. Honestly, without it, I would have spent ages trawling the internet and Google trying to put together the list of commands I need to make these videos possible. So yes, Gemini's help has been invaluable. And the idea is that now you've got a network location where you can actually start sharing information, files, images, videos, whatever your needs are freely between your home network devices, including setting up a media server if that's what you want to do. My first project's going to be a Raspberry Pi hole server. I want to set up DNS and things like that. So that's going to be the second immediate follow-up project, the first project that's going to benefit from the work we've done in this video. And then just as a proof, we are going to paste in a test image to verify that we can write to the location and access the files that we've shared in this location pretty much anywhere on the network. And as you can see here, this is a picture from a night out. And that's the whole point of this video, sharing information freely between these network locations that we've gone through all this trouble of setting up. And to get this to work, I made things easy by myself by using SSH access initially, so that it's easy to copy and paste commands freely from Gemini. And the process is ridiculously simple. You do a sudo apt update, you install the actual Samba package itself, you make a copy or a backup of the config file, you nano or use the built-in editor such as Vi to open the config file, you add this pre-generated block of text that Gemini has put together. If you ask Gemini, Gemini can script this for you with the right settings for you. For example, it's picked the right default user, it's picked the users group, it's given us writable access to it, and it's given us the right permissions using these masks. So once again, this is how incredibly useful Gemini is for navigating the world of Linux. Then it recommends setting up a username and password because it maintains its own database, which once again, Gemini is useful again because it's educating you and it's telling you that Samba has a separate database system separate from Linux. So it totally makes sense to stick to the same usernames and passwords you've used so far in the video series. I've done the same thing. And then finally, it asks you to restart the two different daemon servers that are set up. And then that's it. That's honestly all you have to do to finally expose your new network location. And I may as well make a special mention for the fact that you can also map your new network location as a drive. So it's always immediately available for you. So you don't have to save the credentials or reconnect the drive manually. You can just do it from this menu here using Map Network Drive, which should be fairly familiar with a lot of Windows users because it's kind of the same concept going back almost 15, 20 years. So that is it. Thank you so much for tuning in. I really appreciate it. It's been quite exciting, quite a lot of work and a labor of love getting the project and getting the Raspberry Pi to this stage. And I look forward to seeing you guys in the next video where we're hopefully going to set up Docker and the Raspberry Pi whole server on there. See you then. Thanks, guys.